All right, so let's talk a little bit about conformation. So I want to show you ethane. Okay, this is a small molecule. Of course, you know the structure of ethane. It's just two carbons with hydrogens, okay, all around. So this is the model for it. So when we look at the different projections, the first thing I want to show you is the projections. All right, so here, this way, when you look at this, this is called the sawhorse projection or the Fisher projection, where you're looking at it a little bit from the side. When we're looking at a Newman projection, we are looking at it directly at the atom. Okay, so this is sawhorse, this is Newman projection. Now, the sawhorse projection can be for more than two atoms, because if you have a long chain, that can go on. Okay, so sometimes it can get confusing. So if I have a longer chain like that, then it becomes really hard for me to draw the sawhorse. Okay, so the Newman projections are going to be a little bit better for us when we start doing conformations, especially for the straight chain compounds. Okay, so right now we're focusing on ethane, which is a straight chain. So here is the sawhorse projection, and then here is the Newman. Now the thing about Newman projection is that you look at two carbons at a time. Okay, so when you look at two carbons at a time, you have a front carbon and then you have a back carbon. So how do you draw those out? You draw them like this. Okay, so here is the sawhorse projection that I drew out before, that I showed you in the model, and then here is the Newman projection. In the Newman projection, then the triangle, sort of the 3-point junction, that is going to be the front carbon, and the circle is the back carbon. Okay, that's how you look at it. So this is going to be our Newman projection for ethane. And so here is ethane. Okay, so now when you're looking at two carbons, it's going to be a little bit hard for us to look like this, because if you look at it this way, you cannot see the second carbon. And you also sometimes cannot see the second atom. So what we do generally is just kind of twist it a little bit when we're drawing. Okay, so let me draw out the Newman projection for that kind of a conformation where the atoms are right behind each other, because you're not going to be able to get them right behind each other. Okay, that's not going to be possible. So here, this is what it's going to look like. Okay, so in this case, you can see it's just slightly off, okay, from behind, and that's okay. Okay, and that is still considered to be the right way of drawing it. Okay, the main thing you want to make sure when you draw these is that, you know, the hydrogen here is on the right side. So this hydrogen is also on the right, and this hydrogen is also on the right, just to maintain the bond angles. Okay, so here we are with the Newman. Now you understand what we're doing here. I can show you exactly what the Newman projections help us understand. So here's the ethane molecule, and here are the two hydrogens. Again, I'm just going to go ahead and tilt this just slightly. Okay, so this Newman projection for ethane, now this one is going to be what we call the eclipse, okay, where you have the two atoms right behind each other. And then let me move this around. So this one now is going to be where you have, it's a 60-degree rotation. Okay, so in the 60-degree rotation, what's going on is that this hydrogen and the top hydrogen, they have a dihedral angle of 60 degrees. You rotate it once more, and then these two hydrogens are going to be right behind each other. Okay, you rotate it another 60 degrees, and then this is how it becomes. Now this looks very similar to what we had here, right? And that's because this is ethane. All right, and so you don't really see a whole lot of stuff going on. But if I change one of these with another atom, let's say chlorine, then you can see how things are going to be a little bit different. Okay, because now when I put the chlorine right behind the hydrogen, now you can see the movement a little bit better. Okay, and pardon my recording here, but this is how it goes. Okay, so here is the 60-degree angle, then another 60-degree angle where this chlorine is right behind this hydrogen, another 60-degree angle. So now it is 180 degrees away from where it was before. Another 60-degree angle, so now it's on the left side here, another 60-degree angle, and it's up here, and another 60 degree, and we're back to what we had before. Okay, so this is Newman projections, and then these are the 60 degree orientations that you have. Now you might be thinking, okay, what's going on? What am I looking at over here? I don't see any difference in any of these structures. Well, the only difference you're probably seeing is this one and this one, right? It's like, okay, fine, you know, this is a little bit different, but that's because ethane is a small molecule. So conformations don't really matter so much for ethane. But as soon as you start having larger molecules, then you're going to have a problem, okay? Because what happens is there's all of these atoms, they're occupying space. So if there are more atoms occupying the space over here, they're going to start colliding, right? They're going to occupy the same space, which is what we call the steric tension, which I'll start calling steric hindrance also, okay? So that it's a little bit easier for us to understand. There is tension going on, but the steric space or the spatial space is getting a little bit too crowded, okay, in there. So that's what we're going to do with in butane, okay, in the next one.